Today, I am now going to start superconductivity, introduction to superconductivity. So, in this series, we will discuss about in details about superconductivity, some formulas which are important for CSIR, NET, GATE and any other exam. So, let's start discussion. What is actually superconductivity or superconductors? We have all listened about conductors. We've all listened about conductors, we all know. But what about superconductor? If we add a prefix before it, then what do we mean about superconductor? So to know about superconductor, first of all, we have to know about superconductivity. So what is superconductivity? Let's discuss about that. So let's start discussion about superconductivity. So actually, there are some certain material. Sorry, let my pen color thin. Some certain material which will be cooled. Some certain material which will be cooled below a transition temperature. That means, suppose you have a material, some certain material. I am saying some certain material, not all material. Suppose we have some certain material which will be cooled below a transition temperature. A transition temperature, suppose Tc. So below transition temperature, if which is cooled below a transition temperature, then what will be happen below transition temperature? Below the transition temperature, this material, the material we have taken, this certain material, the material we have taken, its resistivity becomes 0. Resistivity means not resistance. Its resistivity of that material becomes 0, that below that transition temperature. Resistivity of that material becomes 0 below that transition temperature of that material. And they call what? They show a property. Which property? They show diamagnetism. Diamagnetism is what? Whose susceptibility is -1. We all know that what is diamagnetism, whose susceptibility is -1. So what we know, what we learned here, so in the nature there is some certain material. If we cooled that material below transition temperature, then what will be happen? Their resistivity becomes 0, and they will show what? They will show diamagnetism. Diamagnetism means what? Whose susceptibility is negative, -1. So this property is known as what? So all this property is known as superconductivity. All this property is known as superconductivity. So perfect diamagnetism mean what? Now some of you will ask, what is diamagnetism or what is perfect diamagnetism? What do you mean by perfect diamagnetism? Actually what? First of all, to understand about the perfect diamagnetism, you have to know the Meissner effect. Meissner effect what? Suppose you have a material. And here external magnetic field is, let me change the pen color. Here external magnetic field is applied and internal magnetic field is 0. And magnetic flux, external magnetic flux passing outside the material. Suppose you are watching such conditions, then it is called Meissner effect. So why it is in such condition, and why we are seeing such conditions, why and why it is happening in the nature. So we'll see perfect dimagnetism, how it works. Whenever resistivity becomes zero, means what? We all know that resistivity inversely proportional to conductivity. That means whenever resistivity becomes zero, then conductivity is what? Conductivity becomes infinite. Okay. See, resistivity zero, conductivity becomes infinite. That means what? We all know the another relation of Ohm's law. The relation of Ohm's law is what? J equals sigma into E vector. So whenever conductivity becomes infinite, so from this relation we can see what? Electric field equals J by sigma, conductivity infinite, J by infinite. That means electric field is zero. Electric field zero, and that implies what? Inside magnetic field is also zero. Inside magnetic field of material is also zero. Electric field zero, inside magnetic field is also zero. Now we know what? We know that if B inside is zero, it implies what? It implies that mu naught into H plus M. This is a formula of this B inside equals zero. So we can say what? H equals minus M. Now what is the formula for susceptibility? Susceptibility means what? Susceptibility means chi equals magnetization per unit magnetic field. Susceptibility. It is susceptibility. Susceptibility is what? Magnetization per unit magnetic field. So whenever for B in equals 0, you are watching what? You are watching that M equals minus H. So minus H by H, that means minus 1. That means susceptibility becomes minus 1. And that is what? That is the property of what? That is property of diamagnetism. So we can see in Meissner effect that diamagnetism is happening. Perfect diamagnetism. This is the example of perfect diamagnetism. So in case of Meissner effect, we can see the perfect diamagnetism. Because why? Because here inside magnetic field is zero. Inside magnetic field is zero. The material, and we have seen what? Inside magnetism zero, and outside external magnetic field can't enter into that material if inside magnetic field is zero and conductivity becomes infinite. So this is some fundas of superconductivity. So we will see a graph how a normal conductor and superconductor we can relate in the graph. So let's draw that graph. Suppose here along the y-axis, along the x-axis, you are drawing temperature T. Let me change the pen color. You are drawing here along the x-axis temperature T, and here resistivity rho. Okay. So in what condition we can see a material as superconductor? So whenever transition temperature here plays vital role. Transition temperature here along up to this, suppose here I am naming this as Tc. Tc means here the limit of the transition temperature. At the limit of the transition temperature up to this limit, and after that the graph is becoming such like that. So up to this transition temperature, suppose it is some temperature below this temperature, up to this limit, this portion, when a material can show the property of superconductivity. Below this limit, a material can show the property of superconductivity. And whenever the material is crossing the temperature Tc, critical temperature Tc, then it will show normal conductor. normal conductor. So it's first in where it is first in is Hg. It has been first seen in the Hg material, not material. Below Tc, Tc is what? At the Hg for 4.2 Kelvin. 4.2 Kelvin, below 4.2 Kelvin in the mercury, that superconductivity is first observed. So we can describe the material as that. Here I am again drawing that graph, that below Tc material is one superconductor, and after passing the temperature, certain temperature, that transition temperature, the material becomes normal conductor. Yeah. So there is a relation of the temperature dependency of the magnetic field. In this purpose, we can say that HCT, critical magnetic field, equals HC0 into, it is another important relation, HC0 into 1 minus T by Tc whole square. This is very important relation, that critical magnetic field, suppose a critical magnetic field for is Hc at temperature T, and at T equals 0 a critical magnetic field is Hc0. So HCT at temperature T and Hc0, it can be related as HCT equals Hc0 to 1 minus T by Tc whole square. Yeah. Whenever, so what we can see from this relation, that whenever T equals 0, at T equals 0 HCT equals Hc0, and at T equals Tc, transition temperature, critical magnetic field vanishes. At transition temperature, no critical magnetic field, no HCT. So we can show a graph. Here. Here temperature T, here Hc, critical magnetic field. So in the range Tc, there will be superconductivity, because here Hc exists, critical magnetic field exists, and when it is crossing the Tc, here it will become as normal conductivity. So this is a basic things of superconductivity. Basic means very basic. These are very basic things that will be helpful for you. These are very basic things of superconductivity. So there are two types of superconductor. Means, one is type 1 superconductor. Type 1 superconductor. It is also known as soft conductor. So what is the property of it? Property of the type 1 superconductor is 1. It will show perfect diamagnetism. Type 1 superconductor will show perfect diamagnetism, and it follows Meissner effect strictly. So we can see the graph of the type 1 superconductor. Here you can draw M, here you can draw H, here I am drawing minus M. So here Tc is playing very crucial role in the superconductivity, whatever. So up to this limit, the graph will be becoming like superconductor in this region, and here it will behave as normal conductor. It is a graph of type 1 superconductor, and type 1 superconductor perfect diamagnetic means what? Minus M by H, that means minus 1 susceptibility, negative susceptibility. And type 2 superconductor is what? Type 2 superconductor is second is type 2 superconductor. Type 2 superconductor is what? It is also known as hard superconductor. it will not follow Meissner effect strictly. It will follow, but not follow Meissner effect strictly. Not strictly follow. So how it will follow? For type 2 superconductor, whenever magnetic field is below the critical magnetic field Hc1, suppose Hc1, then a limit, Hc1 is limit, another point of critical magnetic field. So below this critical magnetic field Hc1, it will show chi equals -1. Chi equals -1. That means what? Below this critical magnetic field, it will show perfect diamagnetism. Perfect diamagnetism. And in the range Hc1, H less than Hc2, it will show diamagnetism but not perfectly. Here chi less than 0, negative, but not -1. And above the critical magnetic field, H greater than Hc, type 2 superconductor will behave as normal conductor. How we can show it? So let's start showing that. M is what? M is magnetization. Okay. Here M minus M is along the along the y-axis. We are drawing a graph, and H is here. So here is the limit Hc1. Here is the limit Hc2. So how we can draw? Up to this limit Hc1, below this critical magnetic field, it will show superconductivity. Then superconducting properties is decreasing. Superconductive property is decreasing. Then up to a limit Hc2, it will show superconductivity, but chi less than 0 here. Not strictly, it will not strictly superconductor that state. That state is known as mixed state. This state is known as mixed state actually. I had forgot that. And it is known also as the vortex state. Yeah, I remind that. Vortex state. So that's the basic things and introductory thing about superconductivity. We will discuss more about the superconductivity as per my knowledge. So I will discuss the important thing that is very much important and helpful for question solving in the exam of CSR, NET, GATE, etc. So this is the introductory part of the superconductivity. So we'll continue this superconductivity series in my next video. So for the time being, thank you for patiently watching. Bye.